Hello, this is Philip from Marine Magnetics, and in this video, I will demonstrate how to create surface plots in BAM, Bob's Analytics module. To get started, make sure the BAM module is activated in Bob. If you don't have BAM, you can visit www.marinemagnetics.com to request a trial or purchase. In BAM, a surface plot is interchangeable with a grid, a rectangular digital image where each pixel represents a physical quantity, such as the total magnetic field or analytic signal. You will need to already have collected a magnetic survey in Bob to create surface plots. In this video, I will use a Sequest survey over a pipeline. First, we will click the Create Surface Plot tool in the GeoPlot toolbar. The tool's interface is designed to help you quickly turn raw survey data into a visual plot. At the top of this dialog, you can designate the plot name. Below that are the basic gridding parameters, rendering options, basic data corrections that can be applied to improve the resultant grid, and the plot type selection with additional visualization options. You will only need to focus on two key settings to create a basic plot: the survey line spacing and the type of survey plot you wish to generate. You can then use the other parameters to fine-tune your plot if needed. Line spacing allows the interpolation algorithm to determine the correct gridding parameters to use, including the grid cell size. If you aren't sure of the line spacing in your survey, you can use the measurement tool in the GeoPlot window to find the average distance across several survey lines. Please note that while you can plot all the readings in your survey area, selecting specific survey lines can produce cleaner results by eliminating repeated lines or problematic tie lines. We will now select the grid type that we want to produce. For this example, we will select the total field and click Add. The length of the gridding process will vary based on the size of your survey, gridding parameters used, and your computer specs. You will now see the total field plot in the map layers, where you have control over its visibility. Once we have created a plot with the basic parameters, we can enhance the map's features using shading and color scales. I will replot the total field grid with shading applied from the northwest direction at a 315-degree azimuth. This provides natural lighting that helps emphasize geologic or structural features. I can turn the layers on and off to see the difference color shading makes. You may also want to manually adjust your color scale limits. While the software defaults to the high and low values of your dataset, setting custom limits can reveal more detail in magnetic lows or help distinguish anomalies from background noise. To show you this, I will take a previously created analytic signal map. An analytic signal plot, also called the total magnetic gradient, is always positive and ranges from 0 to tens or hundreds of thousands of nanoteslas per meter. This analytic signal plot is shown with a default color scale of 0 to 600 nanoteslas per meter, which is because of the extremely high gradients over the pipeline. At the same time, there is a little bit of noise visible at the low end of this scale, between 0 and 5 nanoteslas per meter. I will regenerate this plot with an upper limit of 100 nanoteslas and a lower limit of 10. You can now see that the pipeline is more clearly defined. For more complex surveys, you may wish to manually set the blanking distance and grid cell size. While these are typically set automatically when you define your line spacing, you can manually adjust the blanking distance to define how far the software interpolates outside of your actual survey lines, which is useful for filling gaps between distant lines. If you are working on a slower computer or with a very large survey, increasing the grid cell size or using the rendering slider can significantly speed up the process. After fine-tuning your plots, you can manage your layers in the GeoPlot panel to reduce clutter by toggling the visibility of paths, markers, and targets. To save your work, right-click on the map and select Export if you want to export the grid as an image, like a GeoTIFF for use in other GIS software, or PNGs and JPEGs for reports, which can include your coordinate grid, scale bar, and north arrow. You can also select Export to save your grid as a GXF file for further post-processing in other software. Using the workflow outlined in this video, you will be able to easily create plots from your marine magnetic data. If you need any additional help, check out the other videos on our YouTube channel or visit our website, marinemagnetics.com. Thank you.